Welcome to this NCFE video focusing on maximising success in the Science T-Level Core Component exams. This video applies the tips given for the multiple choice, short answer and long answer questions from the Maximising Success for the Health and Science T-Levels video to science examples. Here is a multiple choice question around particles and radiation. You are presented with the diagram showing a radioactive source that is placed 8 centimeters away from a Geiger counter, with point A marked in the middle. It then tells us that a physicist has placed different sheets of material at point A and recorded readings from the Geiger counter, which are then shown in the table. The information given in this table is key to answering the question as to what type of radiation the source is emitting. Firstly, we're going to try and answer the question before checking the options. We can see from the table and the readings from the Geiger counter that paper has no effect on the radiation being emitted from the source. This therefore rules out alpha particles as being emitted. Due to its low penetrating power, it would have been stopped by paper and therefore the count rate would reduce. Next, we see that the count rate is reduced when aluminium foil is placed at point A. This would suggest that the radioactive source is emitting beta particles, as they have medium penetrating power and therefore cannot penetrate the aluminium foil. Finally, we see that there is still radiation detected from the radioactive source when using aluminium foil and lead sheeting. This suggests that there is also gamma radiation being emitted, as it has a high penetration power and therefore would be detected even with these two materials placed at point A. To double check this answer, or if you're not sure on what the answer is, it's good practice to then eliminate the other answers. Option B is incorrect, as we know that alpha isn't present. Option C can be disregarded, as the amount of radiation detected dropped when using the aluminium foil. Therefore it cannot be gamma only. Option D, as there was still radiation detected when foil and when lead was placed at point A, this means it cannot be beta only. Therefore, now that 3 options have been confidently eliminated, the correct answer can be chosen, and because of all these reasons, the correct answer is option A. Now let's take a look at an example of a short answer question. In this question, students are presented with a diagram of a specific amino acid. The question then asks to explain the unique role this amino acid plays within the tertiary protein structure. This identifies the context as simply the structure of proteins. First, it's important to identify the command word used within this question. In this case, it's explain, which tells students that they must set out the purposes or reasons that make something clear in relation to a particular situation. An explanation requires understanding to be demonstrated. Linking this back to the context of the question, students must therefore set out the purpose of this unique amino acid within the tertiary structure of the protein. A detailed list of command verbs can be found in the support materials section of the NCFE Qual Hub page for the Science T-Level. It's important to use plain and direct language when answering this question, and remember to use short and succinct statements to answer this question effectively. When applying the knowledge to this question, the main thing to identify is the SH group within the amino acid. This can then be linked to disulfide bridges, which play an important role within the tertiary structure of proteins. These two statements together would achieve the 2 marks as identified within the mark scheme. Finally, we are going to look at how to answer an extended answer question. First thing to check is what the question is asking to be addressed, as there can be some examples which could easily be missed, and therefore a 3-step approach might be useful. Step 1 is to identify the content areas that the questions are addressing so that relevant knowledge can be used, and circling and highlighting on the paper is encouraged for this. Next step is to identify the circumstances. So if it's a comparison, then what is the circumstances for this comparison? Is it comparing uses, comparing durability, comparing safety, and so on? And the final step is to check if there is a particular focus for what is being asked for. If safety was the circumstance of the question, as an example, then check to see if there is a particular focus around that safety. Once the question requirements have been determined, the answer can now be planned. and it's often useful to use a section of the space given for the notes, and here's one approach that could be taken to the plan. Use the space to draw a table with 3 columns, and in the first column, put the facts about the content area in the question. So if the topic area was on lipids, then some facts to include are that all lipids contain carbon, hydrogen and oxygen. They're generally insoluble in water, and so on. The second column is to consider the specific circumstances of the question, and how does that circumstance or situation affect the facts that have been given. Are some properties or features affected by the scenario? Are some of the properties or features advantaged or disadvantaged in that specific situation? And finally, it's decision time. What's the best decision to make with the reasons given? What determination has been drawn, and make sure you include justifications. In this question, a scientist wants to maximise the production rate by finding the optimum distribution for using a catalyst. He passes 2 gases, X and Y, through a reaction chamber, and then measures the rate of production in the outlet pipe in order to determine the reaction rate. The same mass of catalyst was used in each arrangement, but it was carried out at different temperatures. In arrangement A, the reaction chamber was lined with a layer of catalyst. Within arrangement B, the catalyst was in granular form on the bottom of the reaction chamber. And in arrangement C, the chamber itself was divided into a honeycomb structure with hundreds of smaller tubes, each lined with the catalyst. The table shows the rate of reaction in arbitrary units for the different temperatures within each of these arrangements. Based on this information, the methods must then be evaluated in order to find the optimum distribution for the catalyst, making sure data is used from the table to support the answer. This is a complex context, and therefore it's important to follow the steps outlined earlier. First, we need to identify the topic and content area being addressed, which in this case is catalysts and collision theory. Secondly, the circumstances. As described above, this will be applied to the different arrangements of catalysts within the reaction chamber. Finally, we need to narrow the focus of our answer to select the optimum distribution of the catalyst and justify any conclusions made with the data from the table and any relevant knowledge. Using the steps from earlier, we now need to plan and formulate an extended answer. Firstly, it's important to identify the facts that are then going to be applied in this question. These facts will apply to collision theory and catalysts. Some examples of facts that can be included from the mark scheme. A catalyst is a substance that increases the rate of a chemical reaction. A catalyst is not permanently chemically changed during the reaction. Collision theory explains the relationship between surface area and the rate of reaction, as a larger surface area gives more collisions per unit time, therefore a higher rate of reaction. Next, we have to consider the application of these points. So how does the knowledge covered apply to this situation? In addition to this, for this question, it's also important to include any relevant bits of data from the table and relevant comments on the scientific methodology to support any application statements made. And here are some examples of application statements made from the mark scheme. There was no reaction below 70 degrees in any of the catalyst arrangements. The reaction rate increased with increase in temperature after 70 degrees with all arrangements of the catalyst. In all 3 arrangements, once the reaction had begun, the rate appeared to approximately double for every 10-degree rise in temperature, up to 110 degrees. After this, there was a much larger increase. The rate of reaction continued to rise for every 10 degrees up to the maximum temperature investigated. And more examples from the mark scheme can be seen on screen. Finally, we need to be clear on the outcomes of all the information. In this example, there needs to be a clear judgment on which arrangement produced the optimal rate of reaction. As previously referenced, it's important that these judgments are justified using the information we provided. Some examples of evaluations taken from the mark scheme for this question are: Only 3 arrangements of catalyst were used. However, there may be other arrangements which would produce a higher rate. Only 1 amount of catalyst was used. A different amount may have behaved differently. A control was not present. The investigation should have been repeated without a catalyst. The highest temperature investigated was 120 degrees. Despite there being a significantly increased rate at 120 degrees in all 3 arrangements. More examples from the mark scheme can be seen on screen. Having used those steps to formulate a coherent answer, it is then important to proofread that answer, helping ensure no marks will be lost for poor quality of written communication. When proofreading, it's important to check that the answer is well structured, using keywords from the question and plain, direct language. Check that grammar has been used effectively. For example, are full stops and commas in the right place? Ensure a range of appropriate technical terms have been used effectively. In this case, terms such as surface area, temperature, and rate of reaction. Thank you for watching, and we hope you've enjoyed this video.